Imagine a commercial airliner cruising at 35,000 feet. Suddenly, without warning, the navigation system goes entirely blind. The invisible tether connecting the aircraft to the sky snaps, and the autopilot disengages. The system keeping it on course relies on a delicate signal. By the time a transmission from a GPS satellite reaches the surface of the Earth, it operates at roughly a quadrillionth of a watt, a whisper easily drowned out by background noise. Yet modern civilization has tied its most critical functions to that exact whisper. Global shipping logistics, the synchronization of cellular networks, and the timestamps on international financial transactions all require a constant lock on those faint signals. Broadcasting noise on that frequency overwhelms the real data, introducing sudden errors in position and time that ripple through any system relying on that connection. Starting in 2019, receiving stations across Europe began recording massive, unexplained drop-offs in navigation data. From the coast of Spain all the way north to the Norwegian Arctic, the connection would completely vanish. What made these blackouts so alarming was the timing. Stations separated by thousands of miles recorded their signals dying at the exact same fraction of a second. A single jammer on the ground cannot accomplish this. Because radio waves travel in straight lines, the Earth's natural curvature physically blocks them from reaching distant targets. However, a signal coming straight down from orbit bypasses the horizon entirely, blanketing the entire continent at once. Because the Earth is round, the ability to hit Madrid, Berlin, and Svalbard simultaneously leaves only one physical possibility. The attacker had to be operating from space. This image captures the intense solar flares of the Sun, a known, natural space-based jammer. Massive ejections of solar radiation frequently hit Earth and overwhelm global communication networks. But solar interference builds up gradually and lasts for hours. The European blackouts were sharp, violent bursts that vanished after just 3 to 5 seconds. Researchers then evaluated the other artificial objects in orbit, pulling data from commercial transmitters and alternative navigation networks floating above Europe. Signal-to-noise ratio data showed these neighboring satellites suffering the same signal collapse as ground receivers, effectively recording the interference as it passed by them. By ruling out chaotic solar weather and innocent neighboring technology, investigators were left with only one explanation: an artificial, targeted electronic weapon in orbit. To catch the culprit, investigators stopped looking at how strong the jamming signal was and started looking at exactly when it arrived. In February of 2026, 2 specialized receiver stations in Norway and Finland captured a highly detailed 2.3-second window of a jamming event. Sampling data millions of times a second, stations detected a delay between the wave hitting Norway versus Finland. Using time difference of arrival, researchers drew intersecting circles. Their overlap creates a mathematical path, a hyperboloid curve. Tracing this past the atmosphere, they followed the math to exactly 1,200 kilometers. Sitting at that single isolated coordinate on the curve was Cosmos 2546, a Russian military early warning satellite. Mathematical geometry stripped away the anonymity of space, providing the first precise link between continental-scale interference and specific military hardware in orbit. We already know Russia utilizes electronic warfare on Earth. Inside the heavily militarized Kaliningrad exclave on the Baltic Sea, military units frequently deploy ground-based signal jammers. Those terrestrial systems create localized blind spots, intentionally disorienting low-altitude shipping and aviation corridors near the border. But Cosmos 2546 operates differently. It broadcasts on a specific segment of the radio spectrum that intentionally bleeds into the L-band, the heavily protected frequency reserved exclusively for global GPS. The precision of these overlaps suggests an intentional use of the satellite's early warning hardware to project interference across the European theater. Relying on a single, highly vulnerable network of satellites to run planetary logistics is an unacceptable risk. In response, governments are accelerating the construction of independent, ground-based navigation backups. This includes eLoran networks, massive terrestrial radio towers that broadcast high-powered signals, which are much harder to jam. To protect the timing mechanisms that run global finance, engineers are laying secure, subterranean fiber-optic cables to synchronize atomic clocks deep underground, totally isolated from the sky. Meanwhile, modern aircraft are being equipped with advanced inertial measurement units, self-contained internal gyroscopes that calculate speed and position without relying on any external signals. An orbital attack can easily drown out a satellite, but it cannot penetrate a diversified Earth-bound network. The ultimate defense against space-based electronic warfare is ensuring our most critical systems never have to look up to know exactly where they are.